Good morning to everyone. My name is Samar Tomte and I am our aeronautical engineer second year student. Now we are talking about the deflection analysis of the aircraft control surfaces under the aerodynamic pressure. This presentation about the aircraft control surfaces deflection. How parts like ailerons, elevators and rudder move to control an aircraft. It is an important topic in aerospace engineering and aeronautical engineering. We will look at the basic theory, the method used in a study, and it is a real life application and real life effect depends on the control surfaces. Now talking about agenda of why we are presenting this PPT, why we are presenting this PPT. First of all, the introduction to control surface deflection. What is mean by the control surfaces? Control surfaces like the primary control surfaces, the ailerons, elevators and rudders. It is an important control surfaces to move our airplane left, right, for go up, down, for yawing. It is a very important control surfaces. And talking about the aerodynamic pressure basic. The force acting on a wings, rudders and elevator and other control surfaces. It is called as aerodynamic pressure. Structure, modeling and method. How engineers create a model to create a smooth aerodynamic surface. What is the effort to get engineers to create these structures. Then talk about the analysis with the calculation and computer. Now we are using a math. Now we are using a computer simulation to understand the control surfaces acting on the during flying, during landing. And talking about the effect on the aircraft performance and safety, how deflection can change the way of the aircraft. Means we use wings and rudder. With help of wing and rudder, we can move the airplane left or right very smooth. And talking about the solution and the future importance, new ideas, design and the research to make the control surfaces stronger and better way. Then talking about the importance of the control surfaces. Aircraft control surfaces like we can talk about the ailerons, elevators and rudders are the key parts that help to control the planes. This way we can depends on the air pressure acting on them during flight. When how much this part is bend or move, deflect, it is very important to keep the aircraft stable, easy and move to simply. With the help of control surfaces, we can airplane move very smoothly and very easy to move our airplane during flight. And talking about the aerodynamic pressure, what is the aerodynamic pressure? When an aircraft fly, there are around the pushes of the control surfaces like the ailerons. When during a flight, when we are flying, they are working on control surfaces like the elevators, ailerons, and rudder. This rudder is the push the aeroplane. That is called as the aerodynamic pressure. How much pressure acts on these parts depends on the many things like the speed of the aircraft, like the speed of the wind. Then it is important. And second one is the angle of attack. This much is the number of the speed and the move of the and the moving the speed. And the talking about the at a low speed, the pressure is smaller and easier to handle. But at a high speed, the pressure becomes much stronger, and it can even causes the surface bend, change the shape. The bend is called as the structural deformation. In a low pressure, we can fly easily. Means there are no fast no air coming very fast. It is a low speed, that's called as. When it is a pressure, it will be low on control surfaces. When we fly faster, there are control surfaces we get more pressure. In this time, the control surfaces not be bent. It is a very important. Now our control surfaces bend, our flight will crash. Because of this, engineer must create a very accurate model and computer simulation. Now we are using the computer simulation to understand the control surfaces acting during flight. We study next part. This pressure change in over time. This will help to predict how the aircraft will behave and ensure the stay stable, safety, and easy to control during flight. advanced control modeling for the deflection prediction. Now we are using the main tool of to understand the deflection during flying. We are using the main tool like a finite element analysis. FEA. This to know how the aircraft parts bend. Engineering uses a computer model. The main tool is a finite element analysis. We can cut the surface into the small parts, small pieces, and understand how it is a move. Material effect. Some material like composites don't bend in a simple way. And the shape effect. When part bend a lot, there the shape will be changes, which is change the force also. And is a crash airplane. And the air plus structure effect. Air push the surface. Air push the contour surface. Air push the airplane surface. This surface bend and the new shape of the changes the air again. This kind of causes filter. With the help of finite element analysis, we can find out the how much airplane will be bend, how much airplane will be move smoothly. And talking about the computational fluid dynamic (CFD) for the pressure mapping. CFD is used for computer to simulate how air move around the aircraft. You can see there are the green lines are the present. These are the air pressure during the flight. With the help of this simulation, you can understand the how aeroplane moves smoothly, how aerodynamic structure smoothly we can fly. With the help of this simulation, we can identify. And talking about the pressure mapping is a very important for the study how much the surface will be bent. It is important for control surfaces. We can talk about early with the help of control surfaces. We can aeroplane with the help of control surfaces. We can move smoothly, like up, down, left, right, join. Talking about the effect of the too much deflection, less control. Pilot are control. We learn about the pilot can control all of the things, but air pressure, air coming outside. These things pilot cannot be controlled. Pilot can control the plane properly, but not these things. The flutter, strong vibration that can break the parts. This is the very important. Then the beginning is part get tired. Which parts like engines are very important for our aircraft. After certain time, parts will get tired. So it will be also rest. Talking about the limitation. Plane can't fly too faster during turning. There are some limitations. Then talking about the future research to reduce the bending, airplane parts like the wings and contour surfaces should be stronger, but not heavy. It is a very important because heavy airplane cannot move smoothly, cannot lift fast. We need more fuel. This can be doing by using the new lightweight material, special designs like lattice pattern or the smart surfaces that can change the shape when we need it. These are the futures. And about the future research are working on a system that can fix the bending while the plane is flying. This system will be ensure sensor that detect the bending and to make the quick adjustment automatically. Machine learning can help to predict how aeroplane will be bent. That the futures technologies might happen and keep them track the health of the aeroplane part. Our aeroplane will be help of this technique. We can manage our parts. We can keep safe our parts. These ideas will make the future aeroplane safer, lighter, and easier. Thank you for watching.